All right, we are going to learn how to write up and go through conceptually an independent t-test. All right, so let's imagine that I want to know if the evaluation scores are different between teachers who stay in the district versus teachers who leave the district. So my independent variables here, I've got two different groups of teachers. There are two buckets. They're two completely different groups. And so I'm going to do an independent t-test, also called an unpaired t-test. So a very specific research question is there a difference between evaluation scores? In evaluation scores between teachers who stay and teachers who leave. All right, so the word in describes my dependent variables in evaluation scores. Now my null hypothesis then would be there is no statistically significant difference in evaluation scores between teachers who stay versus teachers who leave. All right, now I've got to think about what am I actually doing here. So with the t-test formula, it's basically showing, hey, is there a big difference between those mean scores? And in the null hypothesis world, there's no difference. So in a null hypothesis world, the t would be 0, all right? But if I happen to find a really big T, it would be so rare for me to find a really big T, a really big difference in the null hypothesis world. So I would reject that the null hypothesis is true if I get a really big T. And remember, how big the T is depends on the degrees of freedom, which relates to the sample size. So my null hypothesis says, I don't expect to find anything. And I expect the T to be pretty much in this, it would just be kind of what you would expect in the null hypothesis world. Okay, so I also think it's helpful as you go through these exercises to think, well, what is my alternative hypothesis that I as a researcher expect? So maybe as a researcher, because you've done this research in the lit review and everything, you expect there to be a difference. So you would say there is a statistically significant difference in evaluation scores between teachers who leave versus teachers who stay. So this would be a non-directional hypothesis because you're not really saying which group is going to have more and which group is going to have less. So your assumptions for an independent t-test, the first assumption is always that we assume that this data set is from a random sample, that I picked these people out of a hat or I used a table of random numbers and that's how I have achieved my sample. Then for normal distributions, you're going to look at skewness and kurtosis as normal. All right, so looking here, we see that skewness is within -1 and +1, so that's fine. I don't even need to look at kurtosis. Then I look at skewness of the next group. Hey, it's between -1 and 1. I don't even have to worry about kurtosis. I can go on and assume I'm working with fairly normal distributions. Now the next assumption for an independent t-test, this third hula hoop, has to do with homogeneity of variances. So I've got to understand, hey, is the way that each group varies, remember how you've calculated variance? You've got to make sure that there's not an issue with the variability within these groups, so much so that that accounts for the differences rather than just how the differences are met. So you got to make sure that the variability of scores is pretty much the same. So how do you do that? So I'm not going to walk you through with JMP, but you would go and find the Levene test. And this time you want to make sure that the p-value for the Levene test is above a 0.05. All right, so this is like the Adam and Levine song, and he's dancing like this, and it's like above a 0.05. That's what you're trying to do for the Levene test, because this is essentially saying There's no differences here in the variances. So that's what you want. All right, so my assumption for the Levine's test is met. So I'm going to move on and do the t-test. When I conduct the t-test, I find, whoa, I have a pretty big t. And how do I know that? I have to look at the p-value associated with that. So what am I going to report? I'm going to report this t-value, and I'm going to report this p-value associated with the non-directional null hypothesis. Now, the degrees of freedom, this is really weird, and Dr. Wiemers and I, we really just can't even figure this out. Like, why is it a decimal? It really shouldn't be a decimal, but for some reason it is here. So we are asking that you just take off the decimal, round it to whatever whole number it should be. So the degrees of freedom that you will report will be a 38. And can we reject the null hypothesis? Indeed, we sure can, because the p-value is less than our set alpha. Our set alpha was probably a 0.05 since we are dealing with a data set less than 250. So I'll also conduct power, and I am 99.9% sure that I did a good job, that with this test that I ran, I can be 99% sure that I correctly rejected the null hypothesis. That's what that means. Now, because I found a statistically significant difference, I need to calculate the effect size. Now, there's another calculator that is better for calculating effect size for independent t-test. And so you look it up, you enter the group 1's means and group 2's mean, and you calculate, and it will give you the Cohen D. Hedges G, and also sometimes we'll see a Gates delta. Those are just other types of effect sizes. I'm fine for you to just use the Cohen's D. Hey, it is a 1.72. That is a massive difference. So that tells me the strength, the bigness of how big of a difference there is. So when I write this up for homework assignments, you would report skewness, and then you would report kurtosis if you would have had to look at kurtosis, if skewness was not between -1 and 1. You report that you ran a Levine's test and the assumption for equal variances was met, so you report the p-value. Then you would go on and report the means and standard deviations of each group. Notice that this number in parentheses is the degrees of freedom. And remember, it was a decimal point, but I'm not going to report it as a decimal point. This is the t-value that I calculated in the p. And then I report the 1.72 effect size and the power. So that's how you write up your independent t-tests. Now, again with tables, let's just talk briefly about tables. Would you need to have this if you're just running one independent t-test? No. However, let's say you were looking at other dependent variables, several different things, not only evaluation scores, but also, I don't know what else, the days absent they had, the teachers had, or how many years experience. So you might have looked at group differences on a number of variables. Then it would have been better to include all of this in this type in a table. If you have several dependent variables, I do not think it is a good idea to just have this same paragraph over and over again, okay? What I have provided for you is a template, and I get concerned that when you provide a template, you get template thinking. This is meant to be a guide. We don't need every Lipscomb dissertation looking exactly the same. So if you get the gist of what's involved here, you can reword this in different ways. It's not a good idea to have every paragraph look exactly the same, especially across dissertations. However, I do feel it's important for you to have a guide. All right, so, and remember, in your real dissertation, you do not have to report skewness and kurtosis and Levine's. If it's all normal, just say assumptions were resolved for normal distributions and equality of variances. All right, you guys have a wonderful day.